Hi everyone, so please pay attention. This is a very important video where I'm going to teach you how to test all types of SMD components on laptop motherboard. Upon completion of this video, you will be able to test any SMD component on any laptop motherboard. But please, before diving into the course, make sure you subscribe and click the notification bell to stay updated for future videos like this one. And of course, for anyone who wants to join me in my Patreon page, you are very welcome. I can be your mentor in my Patreon page and assist you via WhatsApp until you fix any computer problem you have. So let's get started. So basically, guys, here we have mini motherboards. So of course, I'm going to teach you how to test SMD components. When I say SMD components, I mean, as you can see here, Mosfets, ceramic capacitors, as you can see here, inductors, electrolytic capacitors, Zener diodes, resistors, Mosfets and transistors, tantalum capacitors, ICs, etc. So let's get started. So let's choose the continuity here, as you can see here, and check first diodes, inductors, and ceramic capacitors, okay? So let's begin from the input here. For example, we have, as you can see here, ceramic capacitor. So to test ceramic capacitors, it's easy. Of course, you can use the continuity option in the multimeter. So if you find any buzzer or any low resistance here, means the capacitor is shorted. So let's check these two, for example, these two ceramic capacitors. As you can see in this multimeter, this is a good capacitor. Let's check the second one also. Here also, this is a good capacitor. If you find like this, as you can see, means the capacitor is bad, okay? Here, basic, as you can see over here, this is inductor, not diode. Why? Because we have here PL, okay? We have PL over here. So let's check this inductor. I should get a continuity in the multimeter. As you can see in the multimeter, means the inductor is good. So here we have two MOSFETs. Basically, we have two MOSFETs. How we can check the MOSFET? So to know about MOSFETs, do you see here this hole over here? Means this is the pin number 1, pin number 2, pin number 3, 4, etc. So always the 3 pins here are source. The 4th pin and gate, and the other 4 pins are drain. So these 3 pins are connected together. If you want, we can even check. So let's put the probe here and check with the second pin, as you can see, and the 3rd pin, as you can see. So these 3 pins are connected together, but this is the gate. It's not connected with the other 3 pins. And over here, these 4 pins are connected together. Why? Because this is the drain. So let's check. This is the second pin, the 3rd pin, and the 4th pin, as you can see. So 4 pins connected together. So if you want basically to check whether the MOSFET is good or not in the motherboard without removing it, you can just put one probe here in the source, the multimeter, and the other probe here, as you can see. We get a reading, as you can see in the multimeter, about 500 drop voltage, means this MOSFET is good, it's not shorted. We can do the same for this one also. So first, let's spot the first pin. Where is the first pin? Here we have the hole over here, means this is the first pin, the second, the 3rd one. So these 3 are source, this is the gate, and over here we have drain. So we should always check between drain and source. As you can see, we should find a drop voltage about 500, 400, no problem. It's the same as you test a diode, okay? So these 2 MOSFETs are good. Now let's move on to this, basically to this component. Do you see this component? This is basically current sense resistor. Okay, so this current sense resistor basically is a resistor with a very low resistance. Means if you check it using the multimeter and choosing, as you can see here, the buzzer or the continuity option, you should get a buzzer or a very low resistance like this. So let's check it, as you can see in the multimeter. Okay, So here basically this is inductor. So this is one type of inductor. Over here we have another type of inductor. This is a very big inductor. Always this type of inductors are connected to power rails. You can never find inductors that are connected to ground, never in the motherboards. So that's why we use inductors to find out the short circuit in the motherboard. So let's check this inductor. Also the same working principle. For the inductor we should get, as you can see here, a very low resistance in the multimeter, as you can see. Means this inductor is good. Here also we have another inductor. Let's check it also. This inductor over here, also low resistance. Do you see this inductor? Basically here we have the high pins and over here we have low. Here we have, as you can see, these two are ground and these two, as you can see, are positive terminals. The 19 volt pass exactly through this inductor. So we can even check. So if I put, for example, one probe here, you see, one probe here, and check here, do you see? So the 19 volt will pass directly here and then pass through this inductor and goes to the side of the inductor. Okay, that's why you should always pay attention to inductors in every circuit, because inductors, if there is a bad inductor, means a cutted inductor, the voltage will stop passing to other side and you will get a dead motherboard. So let's move on here. As you can see, we have basically a Zener diode. Do you see the Zener diode over here? So to check the Zener diode, we should always spot and identify the cathode. Here we have the cathode. Do you see this black line? Means this is the cathode. So we're gonna put the black probe of the multimeter in the cathode and the red probe in the anode. We should find here a drop voltage about 500, 400, 600. So let's check. As you can see, 586. Drop voltage means this is a good Zener diode. So please, here I want to add that this is not Zener diode. Normally this is not a Zener diode. This is a normal diode. Why? Because we have here a black line. Sorry, this is a normal diode. I will show you the right Zener diode. So let's find out here a motherboard where I have some Zener diodes. Okay, so let's check this motherboard over here. Let's check this motherboard. Okay, this is great. Okay, find the Zener diode over here. So do you see, guys? So this is basically the normal diode. Do you see? Here we have this black line. We have the reference D, means this is normal diode. Here we have cathode and over here we have anode. But for this one, as you can see here, this is Zener diode. Why? Because we have the blue line. When you find a blue line like this one, means this is Zener diode. This also is Zener diode. Okay, but for this, as you can see here, this one, this is a normal diode. We have the black line. So then we can move on. Here basically we have other two inductors. So let's check these inductors. We should get a continuity. As you can see, we have the first diode, the first inductor, and as you can see, the second inductor here. So this is good inductors. So then, as you can see here, we have PQ67. This is basically a 3-terminal Mosfet. A 3-terminal Mosfet. So here we have gate, source and drain. Always for this kind of Mosfet you will find gate, source and drain. So let's check it. Basically we should find a drop voltage of about 500 or 600. So let's put the black probe here in the source and the red probe in the gate, in the drain. As you can see, we get 596, means this is a good Mosfet. So let's check this one also. As I told you before, usually or always you will find here, this is basically the gate. Here we have the source and here we have the drain. So let's check again. So here, as you can see, the black probe and over here the red probe. So let's check. I get a reading, as you can see in the multimeter. But if I swap the probes, I should not get any reading in the multimeter. As you can see, no reading in the multimeter. Okay, it's the same like if we check a diode. Okay, the same as a diode, as a Zener diode, as you can see. We get here a reading when we put the black probe into cathode and the red probe into anode. And once we swap the probes, nothing in the multimeter, as you can see. Okay, so then let's pass and check other things. So we're gonna right now check this capacitors. Basically, this is electrolytic capacitors, but first, this kind of component are also like this and like this one. This is inductors. Always for inductors, you should find a continuity, as you can see here, for inductors. Okay, now let's check this kind of capacitors. This is basically electrolytic capacitors. The purpose of electrolytic capacitors is to filter the current in the circuit, okay, to make a pure current and a continuous, a DC. Okay, so it converts, okay, in addition, of course, of the bridge rectifier or the rectifier, it converts the alternating current to DC current. I already made a lot of videos, many videos about this topic. So let's check. So this mark over here, as you can see, means this is the negative terminal. Okay, this is minus. And over here we have plus, as you can see, we have plus here. The same for this one. Negative terminal, positive terminal. So we can also use the continuity option to check all kind of ceramic capacitors. Okay, so we can just put one probe here, the cathode terminal here, as you can see, in the negative terminal, and the positive one in the positive terminal. Do you see? The capacitor charge and discharge, as you can see. The capacitor charge and discharge means the capacitor is good. Let's check this one also. We should find the same. The capacitor should charge and discharge. Oh, here we have a short. Is it a short or not? Let's check this one. This one is good. The capacitor charge and discharge. So let's check this one again. We have a short. No. Guys, this is not a short. Here we have a trick that you should understand. I will share with you this very important tip that many technicians don't know about this kind of shorts, as you can see. We can find this one also with the same reading, as you can see. Is it a short? No. Also, this inductor, as you can see, will give the same reading in the multimeter. So if we put the black probe here and the red probe here, as you can see, you see? This is not a short. This is basically the resistance of the processor. Because the processor is installed in the motherboard, we get, as you can see, this value. So let's check this motherboard, for example. So if we check between ground, as you can see here, and these two inductors, these inductors basically belong to CPU circuit. If we check, as you can see here, you see we get a low reading, as you can see. But if I remove the CPU, here I will not get this reading. I will get a very increased reading. It could be 100 or more. So let's remove the CPU. Now the CPU is removed, as you can see. So let's check again now. So the black probe here in the ground. Let's check the inductor. Do you see? Do you see? We get a high reading. Let's check this one also. Do you see? But if I put back the processor, I will be back to very low reading. So I can even put this, the black probe here, and this, as you can see, the red probe here, and do it in a real time. So I will put the processor So let's put the processor to its place, as you can see. So let's unscrew the screw, and you will see that the short is back. Do you see? Once, okay, let's loose the screw also. Do you see? The short is gone. Basically, it's not short, but it's the CPU resistance. Let's do it again for the last time. Do you see? As when I close this one, the short is back. Okay, guys, so when you check, so remember, when you check component around the CPU or even around the graphic card, around the GMCH or graphic card, you will usually find a very low resistance. This resistance that you find is not a short circuit. It's not a short circuit. That's just the resistance of the chipset, including CPU, GMCH, and ICH. The real short is this one, like this. In the multimeter, you get 0. Okay, this is the short. But if you get like this reading, this is not a short. This is the resistance for the CPU. So let's move on and check other component. For example, this component, this is capacitor. This is, we call it tantalum capacitor. Also, this kind of capacitor is a polarized capacitor. Here we have, as you can see, this bar here means this is the positive terminal. Here we have plus, and over here we have minus. So let's check it. We're gonna put here the red probe and here the black probe, as you can see, the capacitor charge and discharge, as you can see. The capacitor charge and discharge means the capacitor is good. Okay, let's check another one. For example, here we have other two capacitors. Let's check it using the same working principle. As you can see, do you see here we have C, the reference. C means this is the capacitor. We call it tantalum capacitor. Oh, do you see? The same. Is it a short? No, because this capacitor belongs to the CPU circuit. This is the back of the CPU. We get this reading. It's not a short. This one also should give the same reading, as you can see. But this one, no. Why? As you can see, because this one didn't belong to CPU circuit. Here we have CPU circuit, where we have capacitor and Mosfets, capacitor and Mosfets. And over here we have the IC, the processor or the CPU IC. This one belongs to another circuit here. Okay. Now I'm going to teach you how to test ICs. Let's, for example, take this IC. For example, this is the audio control IC that controls the audio. Okay, so how can we check this IC? Basically, you can check this IC or any other IC using three methods that I already shared with you in the previous videos. The first method is by checking the heat of the IC. If you find while powering on the motherboard that the IC is very hot, its heat is not normal, means the IC is bad. The second method is by checking the ceramic capacitors around it. If you find any capacitor that is shorted in both sides, means automatically the IC is shorted. Okay, so for the ceramic capacitors around every IC, you will find that the ceramic capacitor, the terminal of ceramic capacitor in one side is connected to the ground, as you can see, and in the other side connected to the IC, as you can see. But if you find this capacitor is shorted, means the IC is shorted to the ground. Let's check this one. For example, it's not shorted, means the IC is good. Let's check this one. Also, it's not shorted, but this capacitor always is connected to the ground, as you can see, in one side. Do you see? Do you see in the multimeter? Okay, and connect it to IC in this side, in the other side, as you can see. Okay, I will draw for you. So I will draw for you the schematic for this IC and capacitors in order to understand clearly. So do you see? Here is the IC, as you can see. This is the IC basically. Okay, this one is the IC, as you can see over here. And for every IC, you will find ceramic capacitors around it. You will ceramic capacitors around it. Okay, so the ceramic capacitor is connected to the IC in one side, okay, and to the ground in the other side. So if you find any shorted capacitor, means the IC is connected directly to the ground. Okay, so any shorted capacitor means the IC is connected to the ground, not here but in the other side, because the IC connected to the ground in many of its pins. Okay, so this is the second method that you can use to check whether the IC is bad or not. The third method is by checking the inputs of the IC. So for example, let's assume here that this IC will generate 3.3 volt in pin, for example, 19. So to generate this 3.3 volt, the IC should receive some input signals. This is basically input, as you can see, signals. Okay, including enable signal here, 3.3 volt, and the VCC 5 volt, for example. If these two signals are missing, the IC cannot generate the 3.3 volt. So if you didn't find the 3.3 volt, it's not means 100% that the IC is bad. No, you should first check the inputs. If inputs are good, so 100% the IC is bad. So this is it, guys. I hope that you enjoyed the video. Please stay tuned for more videos like this one. And please make sure that you subscribe and you click the notification bell to stay updated for future videos. And don't forget, please like and share video with other people like you. And of course, as I told you before, for anyone who want to join me in my Patreon page, where you can find many useful and exclusive content, including free schematic, laptop schematic, and computer schematic that you can upload or download for free, and of course many tips and tricks and secrets that you can use to repair your computer failures. And for anyone who wants me as a mentor, I can be your mentor and assist you and help you until you solve all computer and laptop problems you have. Of course, if you join me in my Patreon page as a mentorship experience member. Thank you very much and see you in the next video.